So the topic for today is the factors affecting sound, right? So today we are going to talk about those factors that will increase or decrease the intensity of sound, right? Let's suppose if you want to increase the amplitude, or let's suppose if you want to increase uh, the intensity of the sound, or let's suppose if you want to decrease the intensity of the sound. So we need to know about that, what are the factors on which the intensity of sound depends, right? So that is the factor related to factor affecting sound. So the very first factor is related to the loudness, because we studied about different scientific terms, the terms which are related to the frequency, amplitude, wavelength, uh, the distance, time. So all these quantities that we studied in the wave section. Now we need to discuss about that. What are the factors and how these factors uh, affect the sound? So the first factor is the loudness, right? So you know that when we use the word loud, so loud means sound of high intensity, right? Let's suppose if someone shouts, or if someone just scream over there, so the sound produced by that person is known as the loud sound, right? If we increase the volume of the tape recorder or any music player, so that is the loud sound. Okay, so that factor is known as loudness. So basically, in this specific topic, we need to write the scientific quantities or the physical quantities that actually links with these factors, because loudness is a journal term, right? We use loudness in our journal daily life example. So we need to know about that, what is the physical quantity behind this factor of loudness, right? So if we talk about the factor that affect the loudness, so the factor is known as the amplitude. So we may just simply write as loudness depends upon amplitude. Greater the amplitude, louder be the sound, right? So this is the first factor which is related to the loudness. And I hope you know the basic concept of the amplitude, the maximum displacement from mean position, right? The height of the wave.
Right.
So if we increase the height, or if we increase the maximum displacement from mean position, so that factor is known as uh, the loudness, right? Let's suppose if we are having initial wave like this, let's suppose this is our mean position and this is wave, right? And if we increase the loudness, so your new wave will be of amplitude, right? So you can see that we just simply increase the amplitude, because this shows you the maximum displacement and this part shows you the maximum displacement. So now we can see that there is a clear difference between the height of the crust or the height of the trough. So this is the difference between the amplitude, and this difference is generally known as the loudness of sound, right? So let's suppose if there is a diagram given in the form of wave, and to identify the factor of the loudness, so you can just simply identify with the help of amplitude, right? Any confusion?
No.
Okay, so this is the very first factor that is very much important, that is related to the loudness. So always remember the quantity with that is linked with the loudness is amplitude, right? Now let's talk about the second thing. Second factor is related to the pitch of the sound, right? So this is the second factor. So normally in our daily life, if we use the term pitch over there, so pitch means heavy sound or a shrill sound, right? So basically, pitch is a quality, or we can say that it is a factor that helps you to differentiate between a shrill and a grave sound. Grave means a heavy sound, just like if we consider the sound of an old man, right? So you know that the sound of an old man is like a heavy voice. And if we compare with the sound of a girl, or if we compare that sound with the sound of a baby girl or a baby boy, so you know that the sound of a woman or girl or baby are like a sharp noise, right? And if we compare it with the sound or the voice of an old man, let's suppose if we compare the pitch of our sound, let's suppose the sound or the pitch of your sound is greater as compared to the pitch of my sound. So how it is possible and what is the factor actually? So if we want to write about the factor, so basically pitch help us to distinguish between a shrill, sharp, and a very thin voice, like the when we strike some metal surface, or let's suppose if we screech our nails on the aluminium or some metal surface, or just take an example of the voice of a baby boy or baby girl, or we take the example of any female or any girl. So you can compare that the voice of girls or females are slightly sharp as compared to the voice of boys or men, right? Let's suppose if we both compare our pitch of sounds, so your pitch is greater as compared to the pitch of my sound, right? My voice is little bit heavy or like a grave sound as compared to the sound of your voice, right? Shrill and a grave sound. And for simplicity, I write over here shrill means a sharp noise or a sharp sound, and grave means a heavy one, the sound, right? A thick sound. Okay. Any confusion?
No.
And what will be the scientific quantity that helps to increase the pitch or to decrease the pitch? Because loudness depends upon the amplitude, right? And if we talk about the pitch, so for pitch we can say that pitch depends upon C, right? It means that greater will be the sound. We increase the frequency, sound will be if you decrease the frequency, your sound will be a gray sound, right? Let's suppose if we compare with the help of two waves, let's suppose if we are having a two waves over here. So what do you think that in which diagram the speed of, sorry, the pitch of the sound is shrill or the grave in first one or in second one?
I'm not sure.
Okay, just take a look at the definition. In definition, it is mentioned that pitch depends upon the frequency, right? If we increase the frequency, it means greater the frequency, shrill will be the sound. Now, try to memorize the definition of frequency. Frequency is number of waves passing through a point in unit time, right? So, in which diagram there are greater number of waves, the first one or the second one?
I think the second one.
The second one, because in second one we are having three number of waves.
It's
So
more shrill, while
yes,
the first one is like grave.
yes. So in second diagram, frequency is greater. So it means that your sound will be shrill, right? And if we talk about the first diagram, so your frequency is less as compared to the second one. So your sound will be grave, right? So from the diagram, if you need to identify that which sound is shrill, so you can count the number of waves. Okay. Any confusion?
No, sir.
Okay. So these are the two factors. These are the two components that increase or decrease the loudness or the pitch of the sound, right? Now, if we talk about the third one, so the third factor is, and one more thing for the loudness, that loudness help us to distinguish between a loud and a faint sound, right? And further, if we want to talk about the example, so let's suppose if we want to take example of shrill, in shrill sound, we can say that the sound of the girl, or talk about of a sound of flute. These sorts of sound produce a shrill sound because the sound will be a sharp like sound. So that sharp sound is known as, and if we take the example of the grave one, so let's suppose if we want to write the example for the grave sound, so let's suppose a heavy sound, right? If we talk about, so the of that open will be grave, just like the example of man, and these sources will produce a grave sound, right? So this is the difference. And now if we
Oh,
talk about the third factor, so your third factor is related to the quality, right? The third factor, and normally we use this word in our daily life, right? Like the quality of sound is not good of this speaker, or the quality of sound is great of this speaker or of this brand. So we usually compare quality like this in our daily life, right? But if we talk about scientifically, so what is the actual difference between two sound, or how to compare the quality of two sound? What are the factors on which quality depends? So we need to talk about that. So let's suppose first of all we need to write the journal definition of quality. So what will be the journal definition of quality? Quality help us to distinguish between, it help us to distinguish between two sounds of same loud and the pitch, right? So this is the basic purpose of the quality, that the sound of, or we can say that the two sounds of same loudness and same pitch. You can see that if we take same loudness and the same pitch, so it means that the diagram for two sound waves will be same, right? The two diagrams will be of same patterns. The number of waves will be same in both diagram. The amplitude of the diagram or the amplitude of two sounds will be same, right? And what will be the difference between these two sound, or how you compare the quality of these two sound? So there will be a difference in the waveform, right? Or we can say that in the shape of the diagram. Let's suppose if we consider two diagrams. So let's suppose the first one will be like this, and the second one is like this. Okay, so now you can see that the number of waves are same for both diagram, only there is a difference in this pattern, right? If we consider waveform, waveform means the shape of dust or shape of that all points on a same line on crust, or the all points on a same line in trough makes a wavefront of the wave, or the waveform of the wave. So actually the formation of the wave, or the formation of the diagram of the waves, tells you about the quality of the sound, right? Let's suppose if we play two musical instruments at a same time interval. Let's suppose if we consider the first one is the sound of piano, and the second one is the sound of flute, right? So let's suppose if you have good knowledge about the musical instruments, and someone plays these two instruments with same loudness, same frequency, still you can identify that there are two instruments, right? The one is the piano, the second one is the flute, because you know that how the sound of flute actually sounds like, and how the sound of the piano actually sounds like, right? So you can easily identify that there are two musical instruments playing at the same time, right? So that factor gives you the concept of quality, right? Let's suppose if we take the example of a Bluetooth speaker. Let's suppose we have two different brands. One is of very high quality, number one brand, and the second one is of low quality, just a local brand. So if we place same sound on both speaker on a maximum volume, so there will be a difference in the quality, right? The sound of the excellent quality or the good product or the number one brand will be a neat and clean sound, right? But if we compare it with the sound of low quality or the third quality brand, so that will be like dull or a heavy grave sound. So that is the difference in the waveform of their waves, because we know that both are playing on the same loudness, so their amplitude will be same, their frequency will be same, because same music was playing on both speakers. But what is the difference? The quality or the waveform that is going to be produced by both speakers, right? Any confusion?
No, sir.
So this is the third factor that actually depends, or we can say that on which sound depends, or one factor of sound depends. So these are three important factors actually that helps you to identify the difference between different factors of sound, right? So any confusion?
No, sir.
Okay. So this is the end of your chapter, because sound chapter is very much short. Only few examples related to the pitch. Sorry, only few example related to the reflection of sound that we studied in our last class. This one. We discussed that we can use the echo to measure the depth or to detect objects underwater. I will explain you this example in form of question, so that will be easy for you to understand this concept. Otherwise, this is the end of the chapter. Only two important concept in this chapter is, the first one is the echo, because this is completely new topic, and the second one is the factor affecting sound. So you need
Oh,
to
okay.
know about these two important topics from this chapter, because this chapter is very much small and 80-90% of the questions depends upon the question of echo, right?
Right.
So let's suppose if we consider some questions from the topic or from the chapter of sound. So we already discussed about the journal properties of uh, waves. So we need to discuss about sound. So this is the journal properties that we already did. Last chapter is the sound. Okay, this is only for the journal property. So this is a complete worksheet, and now let's talk about the sound section. This is the sound section, right? Okay. So a very first question is related to the factor affecting sound. An intruder alarm is adjusted to give a quieter sound without affecting the pitch of the note, right? So let's mark the factor that was highlighted in the question. An intruder alarm is adjusted to give a quieter sound without affecting the pitch of the note, right? So remember those factor. Pitch depends upon, or we can say that the factor that increase the pitch or decrease the pitch is known as frequency. So pitch depends upon frequency, and quieter sound means low loudness, less loudness. Okay.
Wouldn't the frequency be lower and amplitude low as well?
It depends upon the situation. Let's suppose if my sound is very much low and I'm talking very slowly, so my frequency will be less and my sound will be grave, and my volume of the sound is also low, right?
Yeah,
So quieter sound means your loudness will be
like
less.
like low.
Yes, low loudness, and the pitch, and they are asking without affecting the pitch. It means your frequency must remain same, right? Actually they are talking about, they need to know that
Oh,
that you actually know that what are the factors that link with the pitch and the quieter sound. So we got the concept that quieter
so
sound
like
means less loud, right? So your amplitude will
okay,
be
so it's the amplitude's lower, but the frequency remains the same.
same. Yes, so actually this is the question, right?
Oh, okay.
In which situation do sound waves not travel? That is also a easy question. You may take options by yourself and let me know the answer.
A.
Okay, so in which situation do sound waves not travel? So
Like they don't travel like without medium.
yes, so sound requires medium to travel. So from a satellite in space to Earth, option A is not possible, right?
Because you need something to travel in. Like sound
Yes,
needs something to travel
yes.
in.
Sounds need a medium or sound needs some source to travel from one point to another. Okay, try to
So
answer
silence.
question number 3.
Okay. Y is louder and the higher pitch.
Yes, so in the given question, they are asking about X has greater frequency. So greater frequency means shrill sound, right?
Yes.
And greater amplitude means a loud sound.
Louder noise.
Yes. So Y is louder and higher pitch, right?
Because it like, depends on both
Yes.
amplitude and frequency.
Yes.
No,
So your
pitch
pitch,
relies.
yes. So your pitch will be higher, your sound will be shrill, your frequency will be greater, right? So it means that
Right.
Y is louder and X has, okay,
Excess.
yes, they only mention about Y. So greater loudness means a loud sound but lower pitch, right? Because X has a greater frequency, so the sound of X is shrill than the Y, right?
Yeah.
And Y is only loud as compared to the X, so it means that option B is the right one. Okay.
Oh, okay.
Okay, if we talk about question number 4,
The quality.
okay, actually, in this diagram, you can see that the number of waves are same, right?
Yeah.
We have one, two, three, like 4 waves in this, one, two, three, 4 waves in this. So it means both diagram have same frequency and same
Same
loudness.
frequency, same
Yes.
amplitude. Okay.
Same
Same
amplitude or same
pitch too, I
loudness.
think.
Yes. So only one factor is different. What is the
The
third factor?
quality.
The quality.
Quality.
Because the waveform is different, so that's why the quality is different. So D is the right answer. Okay.
Okay.
Let's try to solve one question related to the echo. Okay, in question number 8, the sound from the siren of a ship is reflected by a cliff, right? Let's suppose we are having a cliff over here and ship is traveling from the left hand side. Okay, let's suppose if we consider the example of the ship. So let's suppose if sound is going to be produced from the ship. So when the sound travels towards the cliff, so it strikes the surface of the cliff and bounce back, right? So that is the meaning of the first line. Next, an echo is heard by a sailor on the deck on the ship 4 seconds after the siren is sounded, right? So you know that when sound travels in forward direction and it reflect back in backward direction, So there will be a concept of echo, right? The reflection of sound. Because when sound bounce back from the surface of the cliff, so we will get the concept of echo, right? So the time is equals to the 4 seconds and the speed of the sound is equals to 320 meter per second. So they are talking about how far. How far means you need to calculate the distance. And if you remember, I mentioned the formula for the echo, that is only one difference in the formula of
Yeah,
echo, that
V
is,
for
yes, do
2D for
2D,
quantity.
because sound needs to travel the same distance twice in this experiment. So that's why V is equals to 2D over T. So we need to calculate the value of D. So we need to convert this formula Vt over that is equals to. So your final answer D is equals to V is 20 multiplied by time divided by, right? So 6 is your final answer, this one, right?
Right.
The formula, and this is the question related to the ship and related to the echo. So these type of question, or this is the practical application of the echo, that it helps the ship to identify the distance between the object or any rock inside or underwater, right? And you also know about that incident of Titanic ship. So usually in the night time or in the night time interval, it is very difficult to observe object from a normal eye. So that's why we use the frequencies of sound or different sources of sound to identify that is there any object nearby the ship or underwater. So these sound waves will help us to identify the any underground, sorry, any
Yeah.
underwater object or any object in front of the ship, right? So
Oh, right.
that's how we use the concept of echo in our practical life. Okay. And question number 10.
Doesn't, yeah, okay. I think it's option D
D. So sound travels fastest in the solid. So we already discussed that. That sound travel fastest in
because
solid.
the
Yes.
molecules are packed tightly.
Yes.
That's
So that's why sound travel fastest in solids. The other one is, yes, question number 12. In an experiment to determine the speed of a sound in air, a student stands 200 meters. So this is the value of distance from a cliff and clamps two pieces of wood together. You remember this experiment? We also discussed this whole experiment, right? His classmates standing next to him start a stopwatch when the two pieces of wood meet and stop the stopwatch when they hear the echo. And there are times. Which value for the speed of sound do they obtain? So we have four set of time period and one value of distance. So how we can calculate the speed of sound? Any idea? You know the formula that V is equals to 2D over T. So we have
yeah
a
for
value
echo.
of distance, but there is a problem with time because we have four values of sound. Sorry, four quantities of time. So what
So
we
we
need
have
to
to
do?
use all of them.
Yes, we need to take average of time. So what we need to do, we need to combine all the time like this. We need
Okay,
to add
adding
them.
them.
Yes, and divided by 4. So that will give you the mean value of the time period, right? So that will give you the concept of mean time, right? So combine all the values, divide by 4.
1.62.
So 1.62 seconds. is your mean time value. So substitute in the final formula. So 2 multiplied by 200 divided by 1.62. So what will be your final answer? So what is your final answer?
Two 247.
So it means C is the right one. Okay.
Right.
So these are some questions from your sound chapter, and this is the sound chapter. I hope this is not much very difficult, and this is also a very short chapter. So these are some questions, these are some concepts related to this chapter. And from next class, we start with the new topic of electromagnetic spectrum. Till then, try to
Ooh.
solve a maximum question from sound section, right?
Yes.
And from next class, we will start the new section of electromagnetic spectrum, right?
All
Related
right.
to the different colors, different frequency, different wavelength of light. Okay.
Oh, okay. Okay.
Any confusion?
No.
Okay.